Welcome to the second episode of NASSCOM Conversations AI Speaks. Today, we're delighted to have a veteran as our guest today, Dr. Alok Agarwal. He's the founder of Scry AI, a company that performs research and development in data science and related areas. Dr. Agarwal, I've known him for a long time as the pioneer for the whole knowledge process industry in India, especially when he coined the term KPO, because before that it was all about BPO. He set up eValue Serve in India, which was the first company that started doing KPO services, and we've come a long, long way since then. He's had a very illustrious career working in IBM and many other organizations. And I think today we're going to talk to him about what's happening in the AI world and really what lies ahead. So welcome, Alok, and thank you so much for making the time for us.
Thank you for having me. Thanks, Sangeeta.
So Alok, I want to start with your book, right? You've written this book on the fourth industrial revolution and 100 years of AI. I know AI has been around for a long time, but I really did not realize it's 100 plus years that AI has already been in existence. But somehow, with the advent of generative AI and ChatGPT, AI feels different. It feels very new now. What do you think? How I know a lot of groundwork was laid in these 100 years, but how have you seen that development, and what has changed now for it to become AI to become a part of almost every conversation now?
Yes, so it actually started in 1950. 100 years, I'm actually covering from 1950 to 2050, covering about 27 more years or 26 more years. In 1950, after the Second World War, there was a research paper written by one of the famous mathematicians and scientists, Alan Turing. Alan was well known already for actually helping the Allies win the war, because he was able to break German cryptographic codes. This was in 1944-45. In 1950, he wrote a paper, "Can Computer Imitate Games?" Essentially. The interesting experiment he posed was the following. Suppose there is a computer in one room, there is a human, a man in the other room, and a judge in the third room. Can the computer imitate the man so that the judge is confused and judge believes that the computer is human? That is how, and in fact, there is a biography or a biopicture about Alan Turing, which is called The Imitation Game. People who haven't seen it are welcome to see it. He's considered one of the biggest computer scientists, and there is a Alan Turing Award, or literally like a Nobel Prize in computer science that's given out. When he wrote this paper in 1952, BBC interviewed him and asked him, so when do you think this will really happen? When will computers be able to imitate humans? And his answer was not for another 100 years. So he's already talking 1950 to 2050, or 1952 to 2052. And then they asked him the next question, which was equally interesting. How do you think computers will get to be there? He said, we'll have to train computers like we train our children. Just like we give our children examples and then we ask questions and validate and test them, we'll have to similarly train these computers also. He called them child machines. And actually, that's what most of our AI algorithms or machine learning algorithms are. They're called supervised machine learning because they're being supervised just like we supervise our children. So it has been around since 1950s. In 1950s, I'll just go back. What was the state of computers? What was the state of electricity and so on? We did not have semiconductors, so we did not have any small chips. Computers were made out of what were called valves, and these were essentially like bulbs. If the bulb is on, then it will be a 1. If the bulb is off, it's a 0. So that's how they were simulating 1 and 0s. And of course, the bulbs fuse very easily. So they would take out, to make these valves, they would take out the air inside the bulb so that it's vacuum, so that the filament will not get oxidized and it will last longer. So this is the period. So semiconductors only came around in 1960s. So this is a period before, in fact, when semiconductors were there. So you could not produce very large computers. In fact, that is how bugs will get in. And that's why the word bug came about, because bugs will get in these computers. They will touch the valves, which are very hot, and they'll die. And I mean, then they will short circuit the computer. And that's how the first word bug came out, thanks to Grace Hopper. I want to remind this history because we have come a long way. In 1965, Intel was formed, and Dr. Gordon Moore, who was one of the founders, he actually said a very, very profound statement, which became Moore's Law. He said that he sees that these semiconductors will become smaller and smaller. Every 2 years, they will reduce in size by a factor of two, and the cost will also reduce by a factor of two, therefore, almost, which implies that in 20 years, it'll reduce by a factor of 2 to the 10, which is 1,028. Indeed, 50 years have gone by, and it has reduced by 2 to the 25, which is about 32 million times. So the power of computer has gone up by 32 million times if you can compare to 1965. Now, that is the main reason why today we can do most of the things. Basically because of Moore's law. The second one is because we have a lot of data. Because of Moore's law, a lot of computers are around. They're connected by internet, and therefore there's a lot of data around. And as I mentioned earlier, to train children, we need data. We need to train them on examples. Here we need much more data, and that data is around. So those are the two main things why things began to move very fast in 2005, after computers became really very powerful and the data was around thanks to the internet. There are other small reasons, but these were the two main reasons that propelled this movement that we see today, which essentially started in 2011 with IBM winning the Jeopardy and opening up everyone's mind that IBM can, that a computer can beat in a game which is not easy to beat, where there are three contestants and they're asked questions about trivia, about general knowledge. Those are the main reasons why we see some of the big changes today. But again, the hype is much more than actually the changes that are occurring. And those who are deeply into computer science realize that this is the third hype in AI. The first hype was after Alan Turing unfortunately passed away in 1956. There was a conference when the word AI was coined. And then researchers got all excited. And Marvin Minsky, who was one of the pioneers, in fact, said that by year 2000, we would have a computer which would pretty much do anything that human can do. And that was the notion of artificial general intelligence. Artificial general intelligence, even though it's not completely defined, implies a computer should be able to do what an average human does. And we'll discuss that more. The hype was so strong that even a movie came out. And this is the second movie I would recommend. Although we're talking about AI, I would recommend more about movies. 2001 Space Odyssey. In 2001 Space Odyssey, they show this computer HAL 9000, who is an artificially general intelligent computer. And one of the discussions that he's having with one of the people who's an astronaut is computer HAL 9000 series does not make any mistakes. All mistakes are due to human error. So that was the hype that got created in the 1960s. By early 1970s, all these pioneers realized that to create artificial general intelligence will take a long time. Maybe Einstein, maybe Alan Turing was right that it may take 100 years. And that was the first hype that died. Then there was a second hype in 1980s. And that hype was not as big as this hype or the very first hype, but people thought again that these computers are going to reign the world. And there was a front page in Business Week which says AI, it's finally here. And you see again today people talking about AI, it's finally here. So every generation, I would say, goes through its AI, it's finally here, or AGI, it's finally here. In my view, it's still far away.
So you're really saying that this is the third hype curve for AI, and every generation has seen it in some form or the other. It feels a little more real to me. I know I've probably not been as involved in the other generations, but just coming back to that whole discussion around super intelligence, we do see AI becoming smarter, the use cases that are now being talked about. Every day there is a new model being launched. There's so much conversation around, this is the potential that AI can do. These are the kind of different use cases. These are the productivity boosters. Just every process can be reimagined with AI. it does make you feel that somewhere the path of AGI or super intelligence seems closer than it was potentially even in the earlier hype cycles, right?
I think AGI may be closer, we are still far away. So first of all, yes, because of Moore's law, because of the fact that computers can work 32 million times faster than what they were doing in 1960s, there is no doubt that we can use these computers to predict and to understand the data from the past and therefore predict the future. That's how we humans learn too. Humans learn by experience, which is looking at the past. So, and an oncologist, a cancer specialist, has looked 25,000 cases about cancer. He or she would be much better in predicting what kind of a cancer it is for the new patient that has come in. The same is true with computers. They can now take a lot of data, and that's why it's called big data, enormous amount of data, and they can learn from that. So therefore, there is no doubt that AI will be very much like motors. In fact, I talk about that in the first chapter, that just like there are about 35,000 motors right now, there would be about 100,000 use cases of AI by 2050. We already have more than 1,000 use cases, and they go all over. I mean, you pick any department, you pick any industry, there are use cases of AI. Some very strong, some not so strong, many boosting basically productivity, and many others fundamentally changing the way we live and the way we will behave and will interact in 10 years or 15 years from now. So that, having said that, the AGI concept is a much harder concept if you look at it. The whole point is literature or language is connected to literature and value system. Whatever, it's not that you and I are simply talking. We also come with our baggage, you can say, or with our value system that has been there since we were born. And the systems, computer systems do not have that particular advantage, or they're not learned through the years. You and I could talk about coconuts being thrown out in water, and it may, I mean, for computer, coconut is no different than a ball and would not understand it. So the context and the semantics aspect of learning over the years, that is missing. And we do not know how to include that. In fact, we are, so there is one of the senior, I would say one of the current very senior scientists, current pioneer of AI, Yann LeCun, who's a professor at NYU and also the head of Facebook. He actually made a very strong comment about 2 years ago, and I put it in the book also, that we have built a very large ladder to the moon. It is not there yet to the moon. It's a very long ladder, and we can do a lot of things with it. But will this ladder take us to the moon? And his view was no. And my view is very strongly no. Because we just do not know how to fundamentally solve some of the issues. Because you and I can talk about, for example, how does a mango taste like? Yeah, because we've both eaten a lot of mangoes and all the good stuff, and we can discuss about various varieties of mangoes. And computer has no such understanding of taste. So you have no understanding of taste, understanding of smell, understanding of all the various other aspects of human senses, or even for that matter, senses that a rat has, that a mouse has. So the whole notion of creating emotions, for example, we are extremely far away from creating any emotions. Yeah, we can make the computer feel like it has emotions, but whether it has real emotions or it can even get close to what humans have is very far. In other words, the HAL 9000 of 2001 Space Odyssey is still far away. And maybe it will happen by 2052, maybe it won't.
Yes, so I think another comment we keep hearing, and some of it may be factually true, is that AI is almost like a general purpose technology. How we thought about the internet, the electricity. So the transformative potential of what AI can be more thought of as a general purpose technology. Do you think its implications will be as wide reaching? I mean, today we can't think about life without internet and electricity, but do you think AI will penetrate our lives to that same extent?
Absolutely, and it will penetrate even more so. So in my first chapter, as you rightly pointed out, the title of the book is The Fourth Industrial Revolution and 100 Years of AI. And the first chapter is actually about the three industrial revolutions and 8 characteristics that they had shown, and the 8 characteristics which are becoming clear even in this revolution, which I believe started in 2011. The first characteristic is there are a lot of inventions that evolution has. It's not just 1 or 2 inventions. And this one has inventions related to data, inventions related to AI, but other inventions like blockchain, like gene editing, and many others, IoT, robotics, a lot of work is going on, climate change inventions. The second is that there is one invention which which creates the infrastructure. For example, in the first revolution, it was the water and steam infrastructure. Canals were created in 1760 to 1840. Second infrastructure was about electricity. Electricity was created. You had electricity generation, electricity transmission, distribution, and consumption. The third is exactly what you talked about, which led to internet really becoming popular, which was electronic communication. Electronic communication, a lot of broadband sea cables were put in the sea, they were put in the earth, and a lot of wireless communication started happening. So that became pervasive. But the infrastructure required about $500 billion. This time we'll have infrastructure about data, because as going back to Alan Turing, you need that data to train these child machines, and therefore this will be the infrastructure about data. You will require a lot of data to be cleansed, harmonized, because your way of looking at revenue sitting in the finance department may be very different than my way of looking at revenue who's sitting in the sales department. And therefore, these things have to be harmonized. We did some study that about if you want to just clean up and make the data useful, about 1% of the data will require about $1 trillion to cleanse.
1% data.
Yeah, so it's not that surprising, especially that we spent $500 billion putting cables around the world to make internet successful. So that's the second characteristic. The third characteristic is there is another invention which feeds on the second invention and becomes pervasive and ubiquitous. Everyone is using it. In the first revolution, it was steam engines. They used steam, and we had steam locomotives or steam trains even until about 40 years ago in India. And around the world, it was at least until 60 years ago. Steam locomotives, steam boats, ships, all of them were basically textile machinery was running on steam engines. In the second one, it was electric motors. As I mentioned earlier, there are about 3,500 different types of electric motors. And if you compare electric motors and what will happen with AI, there will be at least 100,000 different types of AI use cases and AI systems. In the third revolution, it was the processors. It was CPUs. You have them in your smartphones. We don't even think about a processing unit running in our home, in our pockets, and so on and so forth. And those are the first 3 interesting characteristics of the fourth industrial revolution. And definitely AI will pervade. It's already pervasive and will become even more so in the near future.
Especially the whole focus on data and how, data will be the new lever for this AI economy. I think the more we talk about it, the more the potential. In fact, you started the whole KPO revolution, maybe the whole data annotation as a business opportunity is something else that India should focus and build on, because there is a lot to be done there. And I think India does have the people and the talent there.
And I've been talking a fair bit about data annotation since my paper came out, and people didn't realize it, and they think it's all at the low end. And the interesting part, it is not all the data annotation is not at the low end. For example, if you need to annotate data to figure out whether a particular medical X-ray is showing some kind of a cancer, then you need people who are in medical domain, and they would charge substantially. Similarly, if you are going to annotate data about finance, people better have at least a master's in commerce or a chartered accountancy before they can start doing some of these things. So annotation is actually very much like a BPO, KPO process. It spans the entire domain, all the way from doing very simple annotation, this is a dog, this is a cat, versus going all the way to being a medical doctor or being an actuary, an insurance writer, or a finance analyst. And that's something which I personally believe that's something which India is very well suited for, and given its traditions of IT outsourcing, BPO and KPO, it can take on, and it's already taking on, and people are not even realizing what's happening, already taking on in India quite rapidly.
Yeah, I think instead of annotation, we hear fancy words like data engineering, right? So I think it's probably getting subsumed in some of that.
Of course,
But
everyone wants
yeah,
to add engineering, the word engineering to almost
everything.
right? Prompt engineering. Now, I would say
Yeah.
prompt engineering is not really engineering. Prompt engineering is more of an art rather than engineering,
Right.
because
It's like how we would do search, right? I mean, you had to be smart to do search, so you have to be smart to
exactly.
do prompting.
Yeah.
So I wanted to follow up on the whole BPO question and the impact of AI and what it will do to jobs, because clearly we see all these negative articles on how AI will destroy all the customer service jobs because AI can do all of that work, and you will have people who will potentially struggle with what are the new opportunities, and AI can take over everything that is happening. There is the other school of thought which says no, AI will be a more augmentation tool. It will actually help people who are not as qualified to address queries that will be structured, while the more intelligent people or the more qualified people can do the more higher end jobs. It is not about, and we keep getting these arguments, it'll automate tasks, it will not automate jobs. But just want to understand how you're thinking about it, and especially because for somebody who's been actively involved in the BPO, KPO industry, you can, and now doing AI for your clients, how do you see this transition on what is happening to jobs, right?
So let me again go back a bit in history, not 70 years, but only 10 years. So the first article on this, which created a lot of waves in the research community, was published by two researchers at Oxford, Frey and Osborne. In 2013, they wrote a very nice article, which basically said that 47% of US jobs are at stake. That is roughly half of the jobs in US are at stake because they can be automated. So given that US has 160 million jobs, that means about 80 million are at stake. They could be all automated. And the analysis was very, very good. And it actually followed very similar analysis that was done about BPO and KPO as to how many jobs will move from US to India or low-wage countries in early 2000. Similar analysis had been done. Now, the only mistake, in my view, they made was then this could happen in 1 to 2 decades, which means 2013 to 2023 or 2033. Now, by 2023, we clearly have, the world has not lost any jobs. And it's very unlikely that we will lose jobs, large number of jobs to AI by 2033. We are only about 7, 8 years away, and or 9 years away, and it's not at a stage where it shows promise, but it's not at the stage where it's mature enough that it can begin to take jobs. So in my book, actually, in chapter 16, I cover job losses and job gains. And I do say that and I analyzed the whole thing. There were several other papers written after that. We analyzed those also and did our own analysis that yes, jobs will be lost. In fact, around the world by 2050, we believe that about 400 million jobs will be lost around the world. That's 40 crore jobs. That's a huge amount. But there are other aspects that are coming into picture by 2050. First of all, it won't happen in the next 10 years because this particular technology, even though it is very, very interesting, it is going to change the world. Things take time to change. They do not happen overnight. And it is at least 10 to 15 years before the jobs, large number of jobs begin to go away. Until then, it will only augment people by being decision support systems that it will help people become better. It will help a radiologist become better because the computer is saying, look, there is a small dot here, which I think is cancer. You may look at it. Now, this radiologist, she might have overlooked at it. And so this is augmentation or decision support system that the computer is providing. And I think that will happen for the next 10 to 15 years in a major way. But jobs will not be lost. Now we will begin to lose jobs because they will become better. Even without AGI, computers will begin to be better than humans in what they do. And therefore you don't need humans. The interesting part is that we should not look at it in just an isolation, but as a whole, as human society. The interesting part is that human society will begin to taper off around 10, we have 8 billion people around the world now. It will go to 10 billion in 2050. People will be aging. There would be not enough people who would be providing actually work. So right now there are about 36% of the worldwide population is working. That time there will be 32% working. So we'll have a 4% loss right there in the number of people who are working. So 4% of 10 billion is also interestingly 400 million. So when the jobs begin to be lost, we will actually need those computers, almost begging those computers and the robots to help us out, because otherwise we will not have enough people to do the jobs. And the problem that we've seen with Japan, China, not China, but Japan and Italy for sure, where there has been a decline in population, is that unless you have immigration, especially Japan has no immigration almost, if you don't have a working population, your GDP begins to stagnate at best. So we will need computers at that time very strongly to help us out in 2050. Now, there will be other aspects like India, China, other emerging economies will create many more jobs, especially at the lower end, like plumbers, electricians, highway builders, and so on. And of course, there will be more jobs created because the population would be aging, so you need more medical doctors and nurses and so on. But the very fact that you don't have enough workers around the world, I think will have 2 or 3 very major consequences. There'll be much more migration from humans from one area to another, and we will need robots and AI to help us out.
I think fascinating how you think about in the right context, right? But given that, NASSCOM and the work we do tends to be very narrowly focused on the technology and the business operations world, how do you think if you're a company that is providing basic customer services and you employ a lot of people for that, how do you see that? What kind of focus should they be doing? Because their outcomes or the challenges for them may be much more short term as opposed to a 2050 kind of a timeline.
Absolutely. So I'm actually in the process of writing a paper that AI will be transformational to the Indian outsourcing industry, which includes IT outsourcing, business process and knowledge process outsourcing. And of course, customer service is right in the middle of it. And the jobs there will begin to get lost sooner than many other jobs. For example, that of a doctor will be lost much, much later than that of a call center agent or a customer service representative. And I think that that's a place where the companies will have to do 2 things, in my view. Because it will be transformational, one very fundamental way that all of the Indian companies will have to move away from is charging on an FTE model. That, hey, I'll charge you $70,000 per person for this kind of work. I mean, for example, I'm sure TCS goes and provides call center customer service agents, and they were saying $50,000 per person. And they will have to start charging by the amount that the customer is using. So it will be usage basis, just like we pay for electricity on a usage basis, we pay for our Wi-Fi data on a usage basis. And that will be a very fundamental change literally transformational for the Indian outsourcing industry. And partly it will be transformational because it's human nature. If we become successful in something, we always say, what got me here will get me there also, meaning I can go to the next level also. And exactly the opposite happens. The world has changed, and therefore what got me here will definitely not get me there. I mean, if I wanted to start a KPO company today, my likelihood of it failing completely is probably more than 95% because there are so many KPO companies and the world has moved on. So that's one very important transformation that the IT, BPO, and IT outsourcing, all the outsourcing groups should be thinking a lot about, not only in customer service and so.
Sorry.
The second thing, specifically about use cases like customer service representatives, I think there is a silver lining because you can train many of these people using AI. Again, using AI as an augmentation tool, you can take all the data of the past customer service data, like what conversations agents had with their clients. You can take all the data, you can take all the manuals, and it can be fed into AI systems, large language models, to train new AI agents much better, much faster. So India, as we all know, has a very severe problem with attrition that people don't last for more than 3 years on an average, maximum 4 years on an average. And this would actually alleviate some of the attrition and HR issues because you will be able to train people much faster using AI systems, which are being used here. They're being used as augmentation systems. So you will be able to train and educate them faster. And secondly, again, there's a newcomer who is a service agent. If he or she is not able to answer a question that the customer is asking, he can ask the AI system, the large language model, to answer it, which may give 3 answers but he can pick one of those. So again, it is a decision support system which would help. So I think, again, it will be fairly transformational because we are not thinking in those lines. And some of these jobs will begin to go away in the next 7 or 8 years if they are not modified appropriately. And if the companies, which I don't think most companies are thinking, they're thinking at a cerebral level, they're not thinking at a doing level, at an actionable level at this point.
So if I am studying in college today, or for the fresher who's in college today, right, and will join the workforce 5 years from now, what would be your recommendation to him to be ready for this AI augmented world?
First recommendation will be passionate about what you're doing, because it's even in 2050, it's not yet clear that we would have AGI where it'll actually be creative or can actually replace humans in creative aspects. So be passionate about what you do. If you're a writer, write. Be the next J.K. Rowling and create next Harry Potter series. That's number one. I mean, it will be very hard, at least the kind of technology we have, it will be very hard for us to replace humans in the near future. Secondly, don't get worried about AI. It's another tool. I mean, it's no different than what automation did in 1980s, what RPA, robot process automation, did in about 10, 15 years ago. It's just another tool, a very important tool, which will be diversified. But think of it as a tool as we use our smartphones to look at the internet even while we are traveling in a bus or in a car. So think of it as, okay, this is part of something which can help me rather than something that will take my job away. And how can I use it to the best of my advantage?
So working with AI, learning how to leverage AI, I think that's a skill that will become even more important, right?
Exactly. So and that's why it will be transformational, both for students of today and also for companies of today, especially outsourcing companies, IT, BPO outsourcing companies, that they will have to begin to use AI. And the reason I'm saying it's transformational is that because they will have to cannibalize their own revenue. Now, going from an FTE model to, hey, I'll charge you by the drink, you are going to cannibalize revenue to a certain extent, at least in the beginning. Now, hope is that there will be some companies who will not be able to make the transition. Therefore, hopefully, you can be amongst the leaders and take the revenue away in the long run from those companies. But that will definitely be transformational, both for students and for companies.
Thank you so much, Alok. This has been a fascinating conversation.